Hello everyone. In this video, we will do an example which involves computing of expected value of some random variables defined as functions of other random variables. Let's see what is the example. Hannah has 2 dimes and 3 quarters. She tosses each coin once, so in total she's going to toss 5 times. Um, well, there are 2 random variables. One, x is the number of heads that come up on dimes, and y is the number of heads that come up on quarters. So these are 2 different random variables, x and y. X counts the number of heads on dimes, and y counts the number of heads for quarters. So we are supposed to find e of x, expected value of x and y, find the expected value of the total number of heads on both dimes and quarters. And part 3, well, we have a little bit more information to this game. So she wins $2 for each head on dimes and loses $1 for each head on quarters. Find the expected value of the amount of the money, not the number of the heads, but the total amount of the money that she wins in this game. So she has 2 dimes and 3 quarters. Well, the first thing to note is that we are basically counting number of successes. Here success is a head comes up. For x, basically we are counting how many successes, how many heads out of 2 toss of dimes we will get. We know that the chance, the probability of getting head is half, and the random variable which counts it is basically binomial random variable 2 and 1 over 2. And y is also binomial random variable, but this time there are 3 trials, but the chance of winning is half. That's nice. Now, part 1 says find e of x. Well, this is very nice practice of that general formula which says what is b e of binomial np is, that's just n times p. So here if I apply for x, it's b of 2.5, so it will be 2 times half, and that is just 1. How about ey? Well, ey is also binomial random variable, so they are b 3.5, and this is 3 times half, this is 3 over 2. Nice. That's what we have. The second part, we are dealing with another random variable which counts the number of total number of heads. So let me just denote it by z. Z is total number of number of heads. And well, we know that the total number of heads is equal to number of heads on dimes plus a number of heads on quarters. And while we already have a random variable for each one, in other words, this new random variable z is sum of 2 random variables x and y. And if we are trying to find average total number of heads or expected value of that, we know that E works very nicely. This is a good point to recall this. E of ax plus by is aex plus bey. So in this case, a and b are 1, and this is just adding of ex's. Ex is 1, ey is 3 over 2, and when you add them, you get 2, 2 plus 3, 5 over 2. So in average, 2.5 heads will come up. How about the third random variable? The third random variable is the amount of money. So amount of the money won by Hannah. So here, what we know that she will get $2 per head on dime. So if we have the number of heads dime, you multiply it by $2, that's the money she gets for the heads on the dimes. And for the other one, well, that money comes, that's one part. The other part is that she loses, so she will get -1 for each head on quarters. But the number of heads on dimes and number of heads on quarters, these are random variables already. So we have 2 times x minus y. This will be a number in dollar. This will be random dollar basically. And we are trying to find in average how much money she will win. So this will be 2e of x minus e of y. In this case, a is 2, b is -1, and that's why it comes out like that. And then 2 times e of x is 1 minus e of y is 3 over 2. So in average, she is going to win 50 cents.